Today we're going to talk about factoring trinomials that have a lead coefficient. We're also going to look at how in some of these problems we have to use factoring multiple times in order to make sure that we have truly factored completely. Number 1 and number 2 are good examples where we actually will see two types of factoring. In both numbers 1 and 2, we do have this lead coefficient, but if we look closer at the problem, 2 can actually divide into all three terms. They have 2 in common. So the first thing we're going to do is factor a 2 out of this trinomial. When I factor a term out, I write down what they have in common, and then I put a parenthesis that will hold what is left over when I divide 2 out of each term. So what's left? N squared minus 11n plus 28. Now I can continue. This trinomial can actually be split down into 2 more parentheses. I'm going to take this lead term, n squared, and I'll break it down into n times n. Then I'm going to see, are there 2 numbers that can multiply to a positive 28 that can also add to a negative 11? First thing, I know if they multiply to a positive 28, they have to have the same sign. And it's going to be the same sign as this middle term, negative. So can you think of 2 numbers that multiply to a positive 28 that will also add to 11? Yes, 4 and 7. Number 2 is the same type of problem. This lead coefficient, 3, is actually a common term. All 3 of these are divisible by 3. So let's do that. I'm going to write down the 3, and I'll put a parenthesis that shows what is left over when I divide 3 out of all 3 terms. I'm left with x squared plus 2x minus 8. Now I'm going to take my trinomial, and I'll break it down into 2 more parentheses. The x squared breaks down into x times x. This time I have to think of 2 terms that will multiply to a negative 8 that are going to subtract to a positive 2. So how do I know that they're going to subtract? If they multiply to a negative 8, they have to have opposite signs. One will be positive and one will be negative. Well, anytime you combine 2 terms that have opposite signs, you have to subtract them, and you'll keep the sign of the larger term. So can you think of 2 numbers that multiply to 8 and subtract to 2? 2 and 4. Very good. The larger of those 2 terms has to match this middle number. So positive 4 and negative 2 is what'll work. Now, in 3 through 6, you may notice that I have a lead coefficient in every one of these problems. But as I look closer, that lead term will not divide into the other 2 terms. So I'm stuck with it. I can't get rid of it. How do I factor a trinomial that has a lead coefficient that I can't get rid of? There are several methods. I'm only going to show you one. If you need to see some additional methods, just tell me and I'll be happy to show you individually. The method I use, we're going to take this first term, 5, and we're going to multiply it times the last term, 6. 5 times positive 6 gives me a positive 30. So when I break this down into 2 parentheses, I'm going to take this variable, r squared, and I'll break it down into r times r. I'm looking for 2 numbers that multiply to positive 30 that will add to negative 11. Now, just like before, if they multiply to a positive, I know they have the same sign. These are both going to be negative. Can you think of 2 numbers that multiply to 30 that add to 11? 5 and 6. Now, because we had this lead coefficient, we're not done with it yet. We used it in the first step, multiplying it times the end. But now we're going to use it dividing it into each of our terms. Now what you're going to notice, sometimes it'll divide evenly, like it does in this parentheses, and you'll get a whole number answer, r minus 1. But sometimes it does not divide evenly. So what we do, we're going to take the denominator and we're going to bring it out in front of this variable. We're going to write it as a coefficient. So this parentheses will become 5r minus 6. Now there is a way to check. If you want to check and see if you have the right factors, you can use FOIL and go back to your original problem. All right, number 4 is going to be this same type of problem. In number 4, we have a lead coefficient that doesn't divide into all 3 terms. So we're going to take that lead number, 3, and we'll multiply it times negative 35. That's going to give us a negative 105. Now we can split this into 2 parentheses. We're going to focus on the variable, r squared. It breaks down into r times r. And then we're going to try and think of 2 numbers that multiply to negative 105 that will subtract to 8. Now you may not be able to think of all the things that multiply to a negative 105. So first, I do know that since it's negative, I'm going to have opposite signs. Let's break down all the possibilities. 1 times 105, if I subtract those numbers, that's going to be too big. 2 won't divide. Well, 3, yep. 3 times 35. Still, when I subtract that, I'm not going to get 8. So I keep going. 4 won't divide into 105, so let's do 5. 5 and 21. If I subtract those, still too big. 6 doesn't divide, but 7 does. 7 times 15. There we go. When I do 15 minus 7, I do get 8. So which one's positive and which one's negative? The larger number has to match the middle term. So positive 15 and negative 7 will give me a positive 8. Now don't forget, we're not done. Take that lead coefficient, divide it into each of your numbers. Sometimes it divides evenly, like in the first parentheses. That gives me r plus 5. If it doesn't divide evenly, bring it out front. 3r minus 7. And now you're done. Five and 6 are these same types of problems. In number 5, I'm going to take the lead coefficient 2 and I'll multiply it times the last term. That's going to give me negative 6. I'll write down my 2 parentheses. X squared breaks down into x times x. I'm looking for 2 numbers that multiply to a negative 6 that will subtract and give me negative 1. I know they're going to have opposite signs. So can you think of anything that multiplies to 6 when you subtract it will give you a 1? 2 and 3. 3 is the larger term. It has to match the middle sign. So negative 3 and positive 2, when I subtract them, will give me negative 1. I'm not done. Don't forget that lead coefficient. Divide it into each of your numbers. It divides evenly in this first parentheses. That gives me x plus 1. It doesn't divide evenly in the second, so I'm going to bring this number out front as a coefficient, 2x minus 3. All right, here's our last example, just so you can see it one more time. If I take the first term, 3, and multiply it times the last term, I get 63. I'm going to write down my 2 parentheses. I'm going to split my variable, b times b. Since it multiplies to a positive 63, I know both of my numbers will have the same sign, and it's going to be the same sign as the middle term, positive. Can you think of 2 numbers that can multiply to 63 that will also add to a 16? Good, 7 and 9. After you've figured out your numbers, take that lead coefficient and divide it into each of your terms. If it does not divide evenly, take that denominator and bring it out front as a coefficient. So this first parentheses will be 3b plus 7. The second parentheses does divide evenly, giving me b plus 3. All right, these last three examples show us how sometimes we have to think a little bit outside of the box. In number 7, something doesn't look right. It's the exponents. I have something raised to the 4th power and something squared. It is okay though. Remember, when we've looked at all the problems before, we've had a squared term, a single term, and then we've had a constant. As long as your middle term, your middle variable, if you take it and you square it and you get the first variable, then it is still in quadratic form. We've got a squared term, a single term, and a constant. So I can use my same technique for factoring. 2 parentheses. I'm going to take that first term and I'm going to split it. What times what gives me x to the 4th? X squared times x squared. I'm going to look at my last term, positive 50. Can you think of two numbers that would multiply to a positive 50 that could add and give me negative 15? Well, they're going to have the same sign. They're both going to be negative. You're right, 5 and 10. Now, once I get to this point, I should look at each of these parentheses individually to see, can I factor further? Since this is x squared minus, it looks like it could be the difference of two squares. But in both of these parentheses, the 5 and the 10 are not perfect squares, so I can't factor that any further. Number 8. This is another one that looks like it might not work because it's not squared, but it actually is. M to the 4th is really m squared squared. So this is the difference of two perfect squares, and we can use that technique to factor this problem. We'll put down 2 parentheses. We're going to split our squares, and then each of them will get an opposite sign. So I'll have m squared times m squared and 4 times 4. One gets a plus sign, one gets a minus sign. Now I'm not done. If I can continue to factor one of these parentheses, I need to do that. The problem in this first one, even though m is squared and 4 is 2 squared, this is not the difference, and so I can't take this any further. But in the second parentheses, I can. So I'll rewrite this first parentheses exactly as it is, and I'll take this second parentheses and split it again. What's being squared to give me m squared? M times m. What is being squared to get 4? 2 times 2. One of them gets a plus sign, the other gets a minus sign. And now I'm done on number 8. Number 9. You might look at this and realize everything is perfect squares. But before you start splitting it into 2 parentheses, I always want you to ask yourself, do they have something in common? Because you should start your factoring there. They do. They're both divisible by 4, and they both have a u squared. So I'm going to write down what they have in common and divide it out. If I take 4u squared and divide it into 4u to the 4th, I'm left with u squared. 4u squared divided into negative 16u squared leaves me with negative 4. Now I'm not done because u squared minus 4 is the difference of two perfect squares. So let's factor that also. This factors into 2 parentheses. U squared breaks down into u times u, and 4 breaks down into 2 times 2. One of them gets a plus sign, and the other gets a minus. And now I'm done.